First, thanks to the conference organizer for giving me the opportunity to share my research today with you guys. My name is Baek from George Mason University. Today, I would like to present one of my research projects that focused on coupling the local meteorology-induced emission sources with the chemical transport model like a CMAQ. Main focus of this project is to developing the weather-aware emissions for NOAA National Air Quality Forecasting capability by developing the fully coupled air quality modeling system. As many of you already know, there are already several meteorologically induced emission sources coupled with the CMAQ modeling system, like biogenic emissions, ammonia bidirectional, lightning ammonia, sea salt, wind-blown dust, and plumrise calculation for stationary point sources and wildfire sources to improve the accuracy of the air quality simulation. Although these many sources are fully coupled with the air quality modeling system, there are still several emission sources like onward mobile emissions, confined live waste emission sources, and the residential heating sources are not currently coupled with the air quality modeling system due to their limited information and some complexity of the emissions modeling capability. Especially the coupling the onward mobile emission sources with air quality modeling system can be quite challenging because it is a quite complicated emissions modeling sectors, as well as it requires the most computational resources to process many informations to generate the meteorology-induced onward mobile emission sources for air quality modeling system. So in these studies, we will mainly focus on the onward mobile emissions from US EPA onward mobile emissions model called MOVES, Motor Vehicle Emissions Simulator. To couple this complex MOVES mobile emissions sources with the um, air quality modeling system, we had to reinvent the current processing system developing a smoke emissions modeling system, and we were able to develop a new meteorology induced emissions coupler called MetEmis for CMAQ version 5.3.2 for National Air Quality Forecasting Capability application. In 2010, EPA, CMS, and I worked on developing the system called Smoke Moves Integration Tool in Smoke System to develop the weather-aware onward mobile emissions with the meteorology data offline. As some of you already know, MOVES can generate either county level monthly total inventory data using MOVES based on some limited meteorology data, such as monthly average ambient temperature and relative humidity data. Also, there's a way you can generate, there's a capability of the state of the art emissions factor lookup table by various processes like running exhaust processes, extended idling, evaporative, and etc. There are up to 14 different processes, emissions factor from MOVES, and they've been kind of grouped into several processes, such as rate per distance to represent exhaust and evaporative emissions from road type, and they are varied by speed and local temperature. And also they are sorted in a big ask text file for each county for each month. And the rate per vehicle, however, represent the exhaust and evaporative emissions from the off network, such as like your driveway or parking lot. Those emissions factors are sorted by the hour of the day instead of the speed because it's off network, and also sorted by the local temperature. There are several other group the processes to capture their unique characteristics in on-road mobile emission sources. This is what is stored in a MOVES lookup table. Each dot in the figure represents the emissions factor from MOVES lookup table, and this is a rate per distance emissions factor from urban unrestricted access road type. Uh, the one example is gasoline passenger on the top and buses on the bottom. The VOC on the left middle is NOx, and the one on the right is PM2.5. I'm not going into describing each dependency. Just trying to show you how the axis is the temperature, and I wanted to show you how they are related to sensitive to meteorology data temperature value in the x-axis. Some of them has a positive correlation, and while some of them has negative correlation, like a PM 2.5. Next slide is the rate per vehicle for off-network. These emissions are like rate per distance. They're also quite sensitive to local temperature. If you remember the smoke moves integration tool that I mentioned to you briefly earlier, they are based on this data point that see the like a little dots. When you have the graded meteorology value 73 comes out, then what smoke moves does, it reads the 70 emissions factor value from 70 and 75 degree temperature bin and linear interpolate the value to compute the 73 emissions factor to compute the emissions value. Because the smoke moves tool has to cover to run the entire continental United States, we come up with the 315 reference county to represent over 3,100 counties in the United States. And also, we only run for 2 field months to represent 12 months. But because of this 630 different lookup table per day has to be processed for rate per distance, and each lookup table size can be ranging from 85 to 150 megabytes, and total of 630 of them, it can be up to 67 gigabytes to be opened up to process, and then day by day. So processing RPD is one of the slowest sector, and it can take up to 90 minutes per day. So to run the entire month, it takes about 50 hours to run 31 days for the 1 month. So we have to reinvent this approach from previous approach because they are very slow and cannot be plugged into CMAQ because that's going to slow things down. So we have to reinvent this approach. Well, we developed this new approach called MetEmis table approach. It's the simplest and quickest way to process on-road mobile emissions without any computational burden in current smoke monitoring system without losing any accuracy. Also, it generates exactly identical result. There is a program called MOVES in Smoke, which is responsible for processing the current MOVES emissions factor lookup tables. It can now optionally generate the pre-graded hourly emissions data per temperature bin. So meaning we will generate the graded emissions data for every temperature bin and store them into the layer, and we call it pseudo layers. So the layer becomes a temperature bin, and each temperature bin has been storing the graded emissions that has been stored. So this new updated smoke modeling MOVES can generate this 3D structure temperature bin specific pre-graded emissions data table that can be generated, and it can generate the identical result from it compared to the current existing smoke moves integration one, because it's simply interpolating the two graded emissions data, not emissions factor data, from the two temperature bin, which is a pseudo layer in this file. One of the advantages of this approach is that we do not need to run it for every day, but you can run for monthly without any meteorology data. It can generate for month because some of the BMT data has the repeated pattern weekly within a month. So you only need to run maybe 4 or 5, maybe 6 different days, representing days per each month. And that data can be generated upfront, and then it can be read into this CMAQ to compute the graded hourly data based on the graded meteorology data. And then we can interpolate the graded emissions data from two temperature bin and then calculate emissions data on the fly. Another benefit of this approach is instead of you doing that same approach, developing multiple 3D graded emissions data, you can actually combine them all from the multiple sector rate per vehicle, rate per distance. You can actually combine them before you actually give it to CMAQ, and you can combine them and let CMAQ to do the calculating the hourly graded emissions from the table. You still generate the identical result from the offline from smoke to do the individual sector run and combine them later because it's simple linear interpolation and there's no loss of that time. As I mentioned to you, most merge with the existing current approach. It takes 50 hours to run a whole entire 31 days of run. But now with the new this approach, we can actually, in Smoke, we can generate only 4 to 5 minutes per day without any parallelization of the code. So we expect this big enhancement would allow us to do the further next development of the work. So as I mentioned to this finally merged emissions 3D structure pseudo layer emissions data, emis table from multiple segments can be merged and then simply given into CMAQ. And there's a new routine called MetEmis.f will be available to read that in and apply the graded meteorology data to compute on-route emissions data on the fly without any computational burden, without losing any accuracy. And this approach can be utilized for livestock waste ammonia emission sources as long as we can develop this pseudo layer pre-grid temperature emissions data for those particular sources. In this slide, I'm going to show some of the differences on-road mobile emissions from two different approaches. It's completely different approaches that I mentioned to you. Inventory, county level in monthly total inventory approach from moves with the limited monthly average temperature value. That approach is nothing to do with the actual graded meteorology data. That approach versus with our approach with this MetEmis approach. And see how much emissions are different. So the one on the top is a VOC, it's a January on the left and the July on the right. As you can see, the VOC is underestimating compared to the regular inventory mode without meteorologists considered. But so as you see, the blue has the exact same pattern. There's no changes, it's repeated. However, this MetEmis will give you a little bit of fluctuation, but it's not so much because there's so much you can make changes because there's based on the temporal profile was used in MetEmis, but we can add more or lose some emissions based on the meteorology data, but there's some limitation in there. However, the NOx emissions, you see the January, you see some of the increase, but not much. But you see the January significantly greater than the January is a lot bigger. It's almost 20 to 30% increase of the NOx emissions. So we expect some CMAQ result will be changed during that July simulation compared to January. And PM2.5, you don't see much of changes in the PM2.5 as you see, but you see some of the slight changes in ammonia, the PM2.5 changes, especially July 18 and 21 and 22nd. Those days somehow this created more additional emissions in those days. So we're going to look into that a little bit more later. So what is the impact? So the emissions data, those are the time series impact you saw. And let's see the spatially. And you see the one on this is monthly inventory data is, let's call it base, and the MetEmis is the sensitivity cases. So month inventory data is a counted total inventory data that has exact same pattern or routine of the emissions data introduced in an air quality model. MetEmis is the one that we've been working on. BUC, it looks like Canada, the California seems a little bit reduced, but some of the increase. But the amount of the changes does not seem to be big enough to be considered to be a big changes. PM2.5 is similar. There's some increase in the PM2.5 of the city area, but nothing really major. And I'm not showing any January result here in July because there's not much changes in January. However, in the July of the NOx emissions, as you saw in the time series plot, you saw the big changes. And as you can see, it happened everywhere in the country, especially on the southeastern region. There's a huge amount of emissions. NOx is introduced more than the regular monthly inventory base run. So these are the CMAQ result, as you can see, ozone and PM2.5. And as you saw in the NOx, and you can see that those emissions actually starting to impact on ozone simulation. Ozone shows about 2 ppb increase over the Atlanta and North Carolina, that area, and some of the emission changes in PM2.5, but to look at the scale, it's 0.3 microgram per meter cubic, which is not really huge. There's some changes happening in formaldehyde, but the scale is very small. So don't think there's a big changes, it's just a small amount. However, the NOx NO2 emissions changes on the eastern area in a big city and a highway, it does show some of the increase of the NOx emissions in the CMAQ result as well. So because this is study is more focused on the big city, is mostly contributed by the mobile sources compared to the rural area. We picked out some of the location of the city, 8 different cities, and we compared the base versus sensitivity, the PM 2.5 and ozone hourly value, and do the differences and the mean and max differences. So minimum difference is very small, wasn't really much. Ozone, the top table ozone differences, as you see, January, I don't see much of a big issue there. Doesn't make a big difference. I don't see it. But in the July, the NOx emissions seems to shows some impact on Atlanta area, and the base, the sensitivity minus base, the difference is hourly value can be 4 ppb in July, Atlanta area. So we think this result is very consistent to some of the other study that using the same approach. The PM2.5, we don't see much of changes in very insignificant changes happening in here in the CMAQ simulation result. So preliminary result, successfully we coupled the complex mobile emission sources from MOVES into CMAQ for the NAQFC application. And we believe this similar approach can be applied to the other sectors like live waste and some of the residential heating if we can develop proper input data for those sectors. There's no significant local meteorology-induced mobile emissions impact on the local ozone and PM2.5 yet. Um, but we are thinking if we're going into smaller final modeling domain, maybe we'll see a little bit more bigger impact because the mobile source is the most contributor in that region. We'll see some more bigger impact in that region. So we are interested in doing a finer grid cell modeling domain application in the future. And next step is actually we have done the mobile coupling. Now we are interested in moving into combine the livestock emissions from ammonia emissions and then residential heating changes from the winter, summer ammonia increase from the livestock. We'll combine all together into an AQFC application to see whether that improves any of the performance of the NAQFC modeling run. Well, thank you very much. This is what I have for today. And if you have any question, let me know. Thank you.